Hello and welcome everybody for our August session of the Ask Tom office hours about spatial technologies. My name is Karin Patenge. I'm one of the product managers for Oracle Spatial and Graph Technologies in the Oracle Database development team. And I would like to guide you today in our session through the topic of raster data in the Oracle Database. Yeah, let me jump into the topic. So I have prepared a very practical session for today with a notebook style description of what we can do with raster data in the Oracle database. I've also included the description about how to set up the demo or test environment with the Oracle database, how to create the data structures in the Oracle database, how to load the data, the raster data specifically, all the things I will be doing in a practical manner. But before I come to that, just one basic question: what is a raster? A raster is information that is basically expressed as a matrix or an array. And this matrix or array represents a rectangular area on the surface of the Earth. So it is mapped to a specific place on Earth. This matrix typically has non-spatial properties assigned, but also, and that's the important thing to map it to a place on Earth, it has spatial properties assigned. We will be looking at those spatial properties. One of the properties is the so-called spatial extent, which means the bounding box for the piece of Earth that is represented by that raster or raster image. Of course, the coordinate reference system is a very important information that is attached to the matrix or raster. And also we will be seeing information about the resolution of that image or raster. This is the last kind of intro slide before I will be doing the technical session. Rasters in the Oracle database are represented using a specific data type called SDO GeoRaster. And with raster, we typically associate either satellite images, area images, drone imagery, also gridded data provided by meteorological services. And all those data we can store as raster in the Oracle database, manage it there, process it, analyze it in different ways. And we are going to see a few of those processing features and analytical features when coming to the topic of Raster Algebra. What have I prepared for today? I have a demo environment with an Oracle Database 23AI free developer instance running in a container, and this container is deployed on a compute VM in the Oracle Cloud. We are going to see how this was set up. We will be using some client tools. One of the very important tools when it comes to raster data is GDAL. We talked about GDAL in our session about open source components, software components that work together with the Oracle database and spatial. So I'm going to quite a large part of that session today using GDAL. Then, of course, we have our typical client tools to work with the database. One is Visual Studio, including the SQL Developer extension. We can also use SQL Developer as a client tool. I have Spatial Studio up and running to show you how to integrate, how Spatial Studio integrates with raster data. And one tool I haven't set up for today, but for a future session, this is the Oracle Spatial GeoRaster Viewer or ETL tool, which we provide as part of the Oracle Spatial Technologies and tooling. The next important thing is that everything I'm going to show is available as a script in my GitHub repo for the Ask Tom sessions. And I'm going to switch right after this slide to that GitHub repo and follow from there. To set up the Oracle database, you will see that I've used the images or an image provided in the Oracle container registry. There you can find the link to the container registry, and to run the Oracle database in a container, I'm going to use Podman. With regard to documentation, of course, there is the Spatial GeoRaster Developers Guide available. I have here the link to the version 23, but you may know that we have been supporting Oracle GeoRaster for many versions, and it's been enhanced with every version of the Oracle database. I've also included the documentation to the Oracle Cloud infrastructure, especially to set up a compute instance, and two very important things you can find in my Oracle support. The first thing is a patch. The number of the patch is given here, and this refers to this Spatial GeoRaster Viewer ETL tool. You can download from there and install it locally or on a compute instance in the Oracle Cloud. And the second thing we update and manage via my Oracle support is a GDAL build that includes the drivers for the Oracle database to store vector data first and raster data. And this is a package we built using GDAL and the two drivers, and we provide that via my Oracle support. You can download it from there. The MOS node you can find here. Okay, so much for now. Let me put that down. I promised to show you that we are going to follow the description I've prepared on the GitHub repo. And what you might remember from previous sessions that I have a GitHub repo for the spatial series. It's 24, and we have here the scripts and everything for the raster data session we are doing today. Let's get started with this one. So maybe you're not all familiar with setting up an Oracle database in a container, and I would like to take the occasion to walk you briefly on how I set up the compute VM on the Oracle Cloud, how I installed all the required software components, how I set up and configured the Oracle database. And one important thing is, since I'm also using several client tools. I mentioned SQL Developer, Visual Studio with the SQL Developer extension, or Spatial Studio. All these client tools are locally on my machine, and in order to get access to a database that is running in the Oracle Cloud or in another cloud, I need to make sure that I have access to that machine. And I'm going to show you how this is done. And then the major part of working with raster data is what I'm going to show here with getting started with Oracle GeoRaster. So let's dive into the first part. Let me go back to this part here. So the first thing we need is a compute instance where we have software components like Podman up and running. I've also set up GDAL with the two drivers for the Oracle database on that same instance. And in order to do that, the easiest thing is to go to the Oracle Cloud, go to Compute, and you see here Overview, and create a compute instance. The Oracle database, the images for the Oracle database on the Oracle registry that refer to the 23AI free developer instance are of two flavors: one full database image and one so-called light database image. I've chosen, you will see it later, the full image, and for that I recommend to spin up compute VM that has enough memory attached. So typically the process of creating compute instance is very easy. You just say create compute, give it a name, tell the process where you want to deploy it and which so-called compartment. And then the easy part here is to just check the defaults or take the defaults, the image for Oracle Linux 8 and compute VM for E4 Flex with 60 gigabyte of memory. So that's completely sufficient to run the Oracle database. Then we need to set up virtual cloud network. I actually have created one before, and I'm choosing this one. I also need to select the subnet, and I'm choosing a public subnet for setting up the connection to the machine, then we need to give it the public key of SSH key pair, and that's basically everything you need to do. Then create instance, and then this instance is created. I'm not going to do that again because I've already set up this compute instance. It's up and running here. So this is my instance I'm going to use for everything I'm going to show you today. Okay, so the instance is up and running. We later need that public IP address to create the connections to that instance. And let me just go further and show you, walk you through which software components we need to install and what we need to configure beside of installing the software components. So the first thing is we want to run the Oracle database in a container. For that, we need Podman, and I've described here what we need to do on the compute instance to install Podman. It's kind of easy. You can follow up on it. Make sure that you have enough memory later for deploying the Oracle database in the container. But if you have chosen this instance, the shape I've shown you for the compute instance, that is sufficient. And that's it. So installing Podman, verifying that Podman is installed, and then we can take Podman to deploy a container image of the Oracle database. And the container images you find here, let me take that one and show it here. So Podman, search container registry. And here you can see that we provide several images for the Oracle database. And the image I'm going to use is, where is it? The Oracle free, this one here, exactly. So this is a full free image, and there is a light image as well, which is about 20% of the size of the full image. And how did I set up the Oracle database in the container? So the way you spin up the container is using this command here. So what we need to do is give it the container name. It's 23i free. We tell the script which ports we are going to expose to the external. I'm also going to define some environment variables we are going to use. And then here is the container image we are going to use to spin the database up. Once that is done, it takes about 5 minutes to have it up and running. We can see that the container is there. Here we have it. Here's a name, gave it. So everything is perfectly fine. If you want to do further checks, just feel free to follow the script and the commands I'm given here to check different parts of the image. What else do we need? In order to run GDAL from outside of the container image, we need to set up the Oracle Database Instant Client. Typically, the Oracle database is shipped with a GDAL distribution. There is one exception. The Oracle database version 23.4 does not have the GDAL distribution shipped within the Oracle home, and that's why I've set it up here as a separate tool using the Oracle database client. This would be also the recommended way if you are more in a developer role. Then you typically don't have access to database home, and you're not allowed probably to install also the database examples, which have additional sample code for Oracle Spatial. So if you're a developer or if you want to be independent of the Oracle database home, then you set up GDAL separately together with the instant client. And here's a way how you install the instant client. GDAL itself has a few to run GDAL, and the Oracle extensions for GDAL to work with raster and vector data. You need to have some libraries shared. And one of the libraries is the so-called libtiff library. This is the one library missing, not already pre-installed, and this is why you need to install that library additionally after installing the client. And now let's check that the database is up and running. This is the way from my compute instance reaching into the container to check whether the Oracle database is up and running. Why can I do this? Because I've exposed the database via this port 1521 to the external machine. This works as designed. let's go further. We need to run GDAL. GDAL is an open source tool that serves for many purposes. Specifically for GeoRaster, we use GDAL to load raster data of the different formats into the Oracle database. And for that, we have the specific drivers to work with SU GeoRaster or to create SU GeoRasters in the database. And there's also a driver that creates vector data in the Oracle database, so the data of type SU geometry. This GDAL distribution is available via my Oracle support. Go there. You have the mouse node previously included in the slide. Go to my Oracle support, download it, transfer it to your compute machine, unzip the GDAL distribution, and then just check it. And that's what we are going to do here. So cd GDAL, and let's see what is there. Okay, so everything looks good. And in order to make GDAL properly running, we need to set some environment variables. And the easiest way to do that is to add the environment variables to your Ash profile, for example. And here you can see every time I log on to the compute instance, I have these environment variables exported. And this way I make sure that I can use GDAL right away. And this is the proof that GDAL is there, properly configured and ready to use with raster data. You also find instructions if you download GDAL from my Oracle support, or if you have the GDAL distribution in the Oracle home, you will find this GDAL setup GDAL config file. It's basically what you see here as setting up the environment variables. There's a little bit more scripting than I've done it here, but that's basically what you find there. Okay, that's everything. We have a compute instance, we have the Oracle database running in a container, we have GDAL installed on the compute instance to load the raster data into the Oracle database together with the client tooling, the Oracle database client tooling. Everything looks good. Let's go to the database. What do you need to configure to work with raster data in the Oracle database? If you want to connect to the Oracle database inside the Oracle container, you can use Podman exec-it. Then you specify the container and SQL plus as a command that you want to connect. And then you can start working with SQL inside the container. What we need to do is we want to have a specific user where we store the raster data. And for this, I have set up a user named askTomUser. This askTomUser stores the raster data in a specific table space. So I set up a table space here that stores the data structures. What else do we need to do? One important thing is, beside the standard permissions for a user to connect to the database, using GeoRaster requires to assign the user the create trigger permission. If this askTomUser is allowed to create raster data in the Oracle database and work with raster data, for that reason, we need to assign create trigger to that user. And that's what I'm doing here using a system user or a sysdba user. Once that is done, we can log out. That's everything you need to do. Spinning up a user, attach a table space to it, then provide create trigger permissions, and then you can connect as that user to the Oracle database. And one last step is that you need to enable GeoRaster per schema. In previous versions, we used to have GeoRaster enabled per database. This is not longer the case. So per default, the GeoRaster support is disabled. And once you have the create trigger permission as the user that wants to use GeoRaster, you can enable GeoRaster on your own by using this sdo_geo_admin enable GeoRaster function. And to verify that it is enabled, you just run this statement here and query if GeoRaster is enabled. That's everything. Okay. Questions so far?
No, we don't have any questions in chat just yet, Karen.
Okay, perfect. Okay. One more thing, I mentioned that I'm going to use several clients I've locally installed. And for that, going back to our instance here, our compute instance, there are two things you need to additionally configure. So the one thing is when setting up the compute instance, you have defined a virtual cloud network and a subnet. And the subnet, if you click on the subnet, you find here security list that is attached to the subnet. And let's check this one. And typically, if you set up a new virtual cloud network with subnets, you have only these 3 ingress routes added. So connecting via SSH to the compute instance, this is required for all compute instances. But what is additional is opening port 1521 to the external. And for just simplicity reasons, I have provided or access via port 1521 to the complete internet. You can, of course, specify a specific CIDR range or a specific IP address, which serves as a source to connect to the database. And typically for a developer or a single development team, we would set up a CIDR range here with a restricted range of IP addresses. But for now, I've chosen the simple way to open it up for everybody. The second step you need to do is, once you have this security list updated, you also need to go to the compute instance and open the firewall to allow port 1520 or access via port 1521. So typically, firewall is enabled and port 1521 is not opened, but we need to open it, and this is done via these statements here. Okay. You can now go to the clients of your choice. Take one of those clients. This is SQL Developer, maybe a standard tool for many of you. If you set up a database connection, a new database connection, what you need to do is defining the user, giving the password, then the public IP address. We access the database via port 1521 and the service name we've defined when setting up the database. So that's it. And let's connect to it. And here we go. The same applies for using Visual Studio, setting up a connection there. So it's similar. Just here, the 2 examples for these 2 client tools. Okay, now leaving everything that is prep work aside, want to start with loading raster data into the Oracle database. And typically what you do when you want to load data, you set up tables where you store your data. And let's do this. So I'm not sure whether you are familiar with extensions or enhancements of the Oracle Database 23AI. I've felt free to include the if exist clause when dropping or creating tables, dropping or creating users. This is a very nice thing to make sure that you don't get an error message returned if something does not exist. So let's do this thing. So we just make sure that we clean up everything. To store raster data in the Oracle database, we need to set up 2 tables. One table is storing the raster image object with a few additional non-spatial information like GeoRaster ID, source file, description, and this is the actual raster image that will be attached to this raster object. So let's create this one. Let's go back. So we've set up the raster images table using column of type SU GeoRaster, and the actual images are stored in the so-called raster data table that is attached to the raster image table. You need to set up that second table as well. What you don't need to do later on, once you load data into the raster images table, the raster images RDT table is automatically filled with the blobs. You will see it when loading the data. Let's create that one as well. Here you see that we have these 2 tables available. Okay, we leave it aside. So because the next step is we want to load raster data into the Oracle database. Right now the tables are empty. Let's go back to our compute instance because there we have GDAL, and GDAL we are going to use to import database, the rasters into the Oracle database. I'm setting up a few environment variables here. I've also included some data files. I need to update this here later on to download the actual data from object storage bucket from the Oracle Cloud. But right now you find data in the repository, and these raster files I have transferred to my compute instance. You see it here as well. But, you see the actual data files I want to upload into the Oracle database. We go further down. So let's start with something simple. One of the commands, GDAL commands, is getting information about the actual raster images. And run this, we can use a command called GDAL info. You've seen before that I can use GDAL info -- version to get information about GDAL version, but running GDAL with the specific file we want to check, you will see that you get information about the actual raster file. And here you see that this raster file is a georeference TIFF file, and you find information like coordinate system that is attached. You may remember that when I talked briefly about what is a raster, raster has properties attached, spatial and non-spatial properties, and one of the spatial properties is the coordinate reference system. So here is the information which reference system this image is represented with. Then you have some information like origin of that image, the size of the pixel, because an image is matrix of pixel or an array of pixel. Then you have the corner coordinate for the extent of the image, and then you find information about how this image is built. And here you see that the image is a so-called multi-band image. So you have here 3 bands, can consider it, or you can associate it with 3 layers of pixel. These 3 layers are stacked upon each other, and the first band is the color interpretation for red, and the minimum value is 0. The maximum value is 255, which means this is an 8-bit representation of the color red. And you may imagine that 2 and band 3 are other colors, and there is this color coding red, green, blue for raster images. So the band 1 is red, band 2 is green, and 3 is blue. And you can also see that there are some statistics associated with the raster data. These statistics were taken automatically from these additional files here on the left side, these auxiliary XML files. Those contain statistic information. And when loading the raster data with GDAL, then GDAL searches for additional information with the same name or starting with the same name, and then reads the data from those additional files as well, and uses those to, for instance, provide some statistic information as well. So this is something you can get preview about your image using GDAL info. Once we have seen this, we want to load the data into the Oracle database. And I'm going to start this and explain later on what I'm going to do here right now. Okay, so let me just go back. I'm sorry, this is live. GDAL info was fine. Started one by one. Cannot connect to the database. That's weird. Okay, let's do it here. Okay, just let me check. I think I know what is missing. So let me go back. GDAL translate master. I'm sorry for that. So let's try it again. Okay. I'm not sure what was missing. Maybe I copied something. Just do it like this, and then okay. The last one, and while the last one is loaded, let me just briefly explain what I've been doing. Let's have a look at the statement. To load raster data into the Oracle database, I use the command GDAL translate, and the next thing is the parameter output format, and the output format is georaster. The input file is one of the georeference TIFF files that is contained in the subfolder TIFF, and it's an image of San Francisco. And what we are going to create is a georaster object in the Oracle database. We are going to use this connection, and when using the connection, you are connected to the Oracle database with the user ask Tom user. There is this table raster images. The table raster images has a georaster column, and this is where we store the raster files. And then we're going to insert the data using the different parameters that are set up for, or the different columns that are set up for the table, creating a georaster ID, providing a description of the source file, and creating the georaster object, and giving the values you can recognize. It's kind of an insert we are doing here via SQL. It's actually the same SQL insert statement used for filling this parameter insert of GDAL translate. And then we can define additional parameters with GDAL translate. One is the so-called block size. This is the size of pixels, the number of pixels, how the image is tiled. So the original size of the image was something like 4099, and then by blocking the image into areas that are 512 as the X value and 512 as the Y value. This is what we are doing when loading the data into the Oracle database. Then we have 3 bands in the data. Here we have an algorithm that is applied when data are overlapping, how the different values are treated. And then we are also defining that we want to have the spatial extent created. And here the blocking is, there is a method called optimal padding. So this is filling out the borders mainly when creating the different block of the specified size. And one last information, typically when you zoom in and zoom out of rasters, in order to have this done very smoothly and fast enough, zooming in and zooming out is done by using so-called pyramids. And the pyramids are stacked zoom levels of a raster image, and those are created automatically when loading the data. And to see the result of that, let's get back to database. So previously we set up this table and it wasn't filled, and so maybe the last one is missing. I need to check it, but okay. So the first 3 images are here, and checking the raster data table, you will see that this is where the tiles are stored, and the tiles now are filled with the different blocks of the raster image. So you have a raster ID, you have the pyramid level for the raster image, you have the band block number and the row block number and the column, and then you have the actual image as a block stored. And for each image, you have also the spatial extent, or for each block, you have the spatial extent as well. So this is how the raster data table is filled automatically when loading up the rasters. Okay, so here we have some more information. You can get some metadata, how big, how much space you consume. Typically when loading raster data, they consume a lot of space. And then it's good to know how much space actually is used by those images. There's also something which I recommend to do. We've seen it for vector data, and there is a function to validate raster data as well. And I would typically recommend to check your raster data whether they are valid or not. Let me check something. Okay, here we go. I didn't say the end, so I'll let back. So data, now we have all 4 images. Okay, so this is how you store raster data in the Oracle database. There are plenty of formats for raster data. You can treat it differently. You have the different parameters to work with, and GDAL provides a lot of functionality to handle the different raster formats. So just check the documentation or reach out to us if you have specific rasters you want to load in the Oracle database. I mentioned that one of the important information, spatial properties when loading spatial data into the Oracle database and also loading raster data is the coordinate reference system. And in the GDAL info, we have seen that this is the reference system that used by or attached to the data. And we have this coordinate reference system inside the database as well. So we can just load the data. And in order to make sure that we have the spatial extent properly defined, what we need to do is going further down here, we need to register the metadata for the spatial extent. And this is how we do it for the raster data. It's similar to what we do for vector data. So just delete it from the existing one and insert it from scratch. So the spatial extent, or the property that requires the information about the coordinate system, is spatial extent that is part of the object definition for SU GeoRaster. And here for that coordinate system, the SRID, so spatial reference ID, is 26943. And here we have dimensions of the north, how big the extent can be. And this is we are going to define. And once we have the metadata registered, the last step here is to create a spatial index, which we can use later in analysis. So we create the spatial index here. So in order to have everything properly set up for the existing raster data in the Oracle database. Let's do one more thing. I want to show you the result of what we have done so far. Let's go to Spatial Studio. I have an instance of Spatial Studio up and running on my machine. Okay, and Spatial Studio here serves as one of the clients. So in order to read raster data from the database, we need to set up the connection. And here is how I have defined the connection. It's the same as we've done it for SQL Developer or for Visual Studio. Once we have the connection in place, we can create a data set using that connection. And if you say create, you can see here that beside tables, views, we can also read data from GeoRaster. And now, based on the metadata that we created, we know exactly where the raster data are. And here we just create a data set for a single raster. Let's take this first raster. So this is a raster data set we created, and we also create a so-called mosaic that contains all the rasters. So all the rasters are currently stored in the database, in that table. And the virtual mosaic is merging all the existing rasters together. So based on this column georaster, and this is our second data set. So now we have the data sets in place. Let's go to the project and add them. Okay, and let's now start with this single image. And this is what you can see here now, that we have a raster image stored in the database, accessible via different clients, can be loaded into a project in Spatial Studio. And one thing I want to show you, when you look at the borders of that raster image, what you can see here are black pixels. Those pixels are created while reprojecting the raster image to the coordinate system that is used by Spatial Studio. We have seen that we have defined or the original data are in the coordinate system 36943. Spatial Studio uses a different coordinate system, and when loading the data in Spatial Studio, they are automatically reprojected to match with the coordinate reference system that is used by Spatial Studio. And for the reprojection, this image is kind of rectified, I would say. So this is why you see those triangulations here at the border of the image, right? And to get rid of those black borders, there is a way to remove those black pixels by a specific treatment that is explained further on in my description, handling no data values. And since it is already the top of the hour, this is what I'm going to leave for the next session to follow up with that part, and then also going further and explain how you can process raster data that are stored in the Oracle database, either merging those to virtual mosaics. We have seen an example of how it can be done using Spatial Studio, but you can also do it directly in the Oracle database. And the most important thing is that you can now use the analytical functions to work with the raster data. And one very nice thing is the Raster Algebra language you can use to do all kind of different transformations, extractions with the data. For example, turning the red, green, blue data to grayscale images, which is easily done in the database using just an operation like this one here. So this is a Raster Algebra expression that you can apply to the existing data in the Oracle database, or you can classify rasters using the classify method or function, giving the raster algebra expression as well, and defining ranges for the classification. And other things like finding certain cell values for the pixels and working with those. So this is what we will be seeing next time. For those who are keen and curious to see it, all the scripts are already available in my GitHub repo, so you can start working on it, trying it out on yourself without a license, or you have the license to copy and paste. Okay, let me just go back to and wrap it up. There are plenty of resources about Oracle Spatial Technologies. Here are a few of those. It's always a good thing also to reach out directly to us if you want to. And yeah, I already mentioned that I want to follow up on the raster topic in September, because I knew for that I won't be covering everything related to raster. So I left plenty of things for next time to talk about. Anything else?
There are no questions in chat. Thank you so much, Corinne.
No,
This was a
no
good session.
questions. Okay, perfect. Then thank you very much and have a nice day, everybody.